Hey everyone, welcome to Concept 32, Angles and their Intersected Arcs. Hopefully you've already spent some time reviewing the first page of this packet. The whole front of it is review, so if you haven't taken a few minutes to go over that, please look at that yourself. That front will not be covered in this video. I'm just going to assume that you've already reviewed that and you are comfortable with those different angle relationships. So here we're going to look at what if the vertex of an angle is not on the circle as an inscribed angle and not at the center of the circle as a central angle. What other situations might you come up with? So the first one we're going to look at today is called a chord angle. And then basically this is just formed from two chords intersecting in a circle, but they're not intersecting at the center of the circle. And we have a simple formula that we're going to use to find or to show how the two arcs that are involved help you to find an angle. And the formula just says that you take arc 1 plus arc 2 and divide by 2. It's just an average. Let's see what this looks like in an actual picture. So look at this first picture here. One way to look at it is if I took arc AC as my arc 1 and I added it to arc BD and I divide that by 2, I could then get either angle BPD, or it could also be angle APC because they're the same thing by vertical angle. So I'm just going to talk about the blue one at this point, but it could be either one because it's a vertical angle. Let's write this out. So we had said arc AC plus arc BD divided by 2, and that will give me angle BPD. Again, it could have been APC, it's the same angle. So we take two arcs, we add them together, we divide by 2 to find the average. In the second picture, we're going to look at the same relationship, just looking at different arc measures this time. So in this case, we're going to look at arc AB, and we would add that to arc CD, and that would give me, when I divide by 2 and find the average, angle APB. Again, it could have been the other side of that, which is a vertical angle. I'll just stick with one side for simplicity's sake. And let's go ahead and write this down. So this would be AB plus arc CD divided by 2 is going to give me angle APB. Again, this is for when you have two chords that intersect inside a circle that are not intersecting at the center. If it's intersecting at the center, we know that the central angle is just equal to the arc. This is for a different situation. All right, in our final picture, we have all the angle measures. We know that arc CA is 170, and we know that arc BD is 70, and we also know that angle X is equal to 120. We're just going to fill all these numbers into the formula to verify that the formula works in this situation. So we are going to take our two arcs, 170 and 70, and we're going to add them together. We divide that by 2, and that should end up equaling my angle measure of 120. Let's see what happens. So 170 plus 70, that comes out to 240. And 240 divided by 2 is indeed 120, and so it works. We're just verifying that it actually works. So at this point, you know how to find any arc or angle measure that's created from two chords that are either intersecting on the circle, at the center of the circle, or somewhere else inside the circle. Next, we're going to look at, well, what if two lines intersect outside the circle? That's on the next part. Okay, so here we're going to look at the situations when you have two lines forming an angle and those two lines are intersecting outside of the circle. And there's three different types of situations this can happen in. It can happen if you have two secants, like we have in this first picture. We have a secant angle, so there's a secant and a secant here. It could happen if you have two tangents, which is a tangent-tangent angle. So you can see we have a tangent here and a tangent here. And it can happen if you have one of each, a secant and a tangent. So we have a secant tangent angle. We've got one tangent and one secant. The good news is, again, just like last time, all three of these situations end up giving us the exact same formula. That formula tells us we take the far arc, subtract the near arc, and divide by 2. Far and near is in reference to the angle that we're talking about. So you subtract those two, divide by 2 to get your angle. Another way of thinking about that is it's half the difference of those two intercepted arcs. So the difference, again, we subtract, and that's going to give us the angle measure. Let's go ahead and write out a formula for each one of these three based on this general formula that we have up here. So in the very first one, if we want to show the far arc, again, we're in reference to this angle right here that's marked, that angle being formed on the outside by those two secants. So the far arc would be this arc out here. So that would be arc CE. And we're going to subtract the near arc, which would be this one here that's close to that angle. So we're going to subtract arc BD. We're going to divide by 2. And that is going to give us, in this case, angle BAD. Okay, in the second situation, we have two tangents. And so we are looking at the far arc being out here. So that one's going to be arc CBA. It's important that we use 3 letters here. If I just said arc CA, you can't tell which one it is. So we want to make sure we point to being that the major arc on the outside there. Subtract my near arc, and that's this one. Since it is a minor arc, we could just say arc CA, but just to be very clear here, I'm going to call it arc CDA. We divide that by 2, and that's going to give us our angle, which is angle X. All right, the final one, where we have a combination of a secant and a tangent. The far arc in this case is going to be out here. Let's try a different color there. Out here, because again, we're in reference to this angle here, angle VUX. So the far arc being arc VY. Subtract the near arc, which is VX. We divide that by 2, and we get our angle, which in this case is angle VUX. So again, the general formula is just far arc minus near arc divided by 2, and we get the angle measure. Let's do what we did last time. I have 3 pictures here, and we're just going to verify that the actual situation is working out. So we're not going to solve for anything, we're just verifying. In our first picture here, we have 2 secants. So the angle we're talking about is right here. So here we have a far arc, which is 83, minus my near arc, which is 30. We divide that by 2, and we should get the 26.5. Let's do the math and see if this works out. 83 minus 30, that's 55, divided by 2. I'm running out of space there, but if we do the math of 55 divided by 2, it does come out to 26.5, so that does verify that formula. In our second one, the far arc is this one out here. This one's made up from one secant, and one tangent. So my far arc is 170. I subtract the near arc, which is Vx, so it's 60 degrees. I divide that by 2, and we should get our angle measure, which we're talking about this one right here, angle VUX, which is 55 degrees. 170 minus 60 is 110. We divide that by 2. and that does equal 55 degrees. All right, our final one is made up of two tangents, and my far arc being this one. Again, we're comparing this as relative to this angle right here. So my far arc, which is 250 degrees, subtract my near arc, which we're talking about this one here, arc BC, which is 110 degrees, divided by 2 should equal that angle measure of 70. 250 minus 110 is 140 degrees, divided by 2 does equal 70 degrees. So again, we were just verifying those three formulas. You do the far arc minus the near arc divided by 2 when they're intersecting outside the circle. Again, on the previous page, when they intersected inside the circle, it's just adding up the two angles, the two arcs, divided by 2 and get the angle measure. All right, so let's do some practice questions. There are 10 practice questions here. I do not think that you need to sit here and listen to the video for all 10 questions. What I would encourage you to do is try them on your own. Try to do the work by yourself. If you finish it, come back and just speed ahead and check the answer at the end. But if you get stuck, you can certainly listen to what I say to describe it, and then try to do the next one on your own. But I don't think you need to sit and listen to the video for all 10 questions. I'm just going to make the video for all of them in case someone is getting stuck. So in our first one, we have an intersection outside the circle. It's outside here. So we're dealing with the situation of the far arc minus near arc divided by 2, because we have a secant and a tangent here. So my far arc is this one, which is arc AC. That's going to give me 178 degrees. I'm going to subtract the near arc, this one, which is CH. That's 102. I'm going to divide by 2, and that should give me angle X. 178 subtract 102, that's 76. 76 divided by 2 is 38 degrees. All right, number 2. This time we are intersecting inside the circle. So we're going to add the two arcs to get our angle. So here we have the two arc measures are 80 and 40. So 80 plus 40 divided by 2 will get angle X. That's 120 divided by 2. So 60 degrees is angle X. All right, number 3. Here we have an intersection happening outside the circle. So that's the formula of far arc minus near arc is going to give us our angle measure. But notice here we have the angle measure, and we're going to be finding one of the missing arcs. So same formula, just a little bit different in terms of how we're going to solve it. So let's start with setting it up. Far arc, that's 158 minus my near arc, which that's my, I'm going to call that, I don't want to use X because I already have X over here. Let's just call that Y divided by 2 is going to give me the angle X, which is 68 degrees. So we're just going to solve it like a typical, algebra problem. How do we get Y alone? First thing I'm going to do is multiply by 2 on both sides. That cancels this out. So now we have 158 minus Y equals 136. Want to get that Y alone, so I'm going to subtract 158 from both sides. Now we get negative Y equals negative 22 degrees. Divide by negative 1, so Y is 22 degrees. Okay, in question 4, we're intersecting inside the circle. That means we're going to add up our two arcs and divide by 2, just finding an average. If I'm looking for angle X, which is right here, I need, the two arcs that I need are here and here. Well, I have one of them. This one is 30 degrees, but I'm going to need this one. Well, I have to do an extra step here so we can see that we have a diameter. And if this arc is 110 degrees, then this missing part up at the top has to make up 180 degrees. So that makes this top angle or top arc 70 degrees, and that's what we're going to need to use. So for our formula, we're going to take my two arcs, 30 plus 70. We're adding those when it intersects on the inside. We divide by 2 to find angle X. So we have 100 divided by 2. So angle X equals 50 degrees. All right, number 5. Again, we are intersecting inside the circle. That tells me that we are going to add our two arcs together. 3x plus 3 plus 10x minus 14. All of that divided by 2 equals my angle of 53 degrees. Let's combine like terms. And we solve. Multiply by 2. So 13x minus 11 equals 106. If I add 11 to both sides, that gives me 13x equals 120, not 120, 117. And then we're going to divide by 13. Thirteen goes in 9 times, so x is 9. All right, number 6 has a little extra added twist to it. We see at the very beginning of this question that we have the fact that arc ABC to CDE has a ratio of 3 to 1. So we don't know their measures yet. We just know that they have a ratio of 3 to 1. Well, we've done a problem similar to this, well, with a ratio anyway, back when we dealt with polygon angles. It's been a little bit since we've done that, but I bet it will come back to you. So we're looking at the arc ABC, which is this one right here, has a ratio of 3 to 1 to the arc of CDE, which is this one here. Well, all that means is the one that has the 1, if we call that x, so if we call arc CDE x, then ABC is 3 times that, or 3x. Also notice that those two arcs make up a semicircle. So we're going to go ahead and find out those two arc measures first. So we're going to write an equation that says, well, 3x plus x must equal 180 degrees, because they together make up this semicircle right here, because we have a diameter there. So we have 4x equals 180, and then we divide by 4. So x is equal to 45 degrees. So now we know that arc CDE, instead of calling that x, now we can call that 45 degrees. And arc ABC is 3 times 45 degrees. Which is 135 degrees. Okay, now we can use the new formula we've learned today that tells us that my far arc of 135 minus my near arc of 45 divided by 2 will equal my angle, which is t in this case. So 135 minus 45, that's going to give me 90. And 90 divided by 2 is angle T. 90 divided by 2 is 45. So it is just a coincidence that that angle ended up matching that arc. That is not always going to happen. So an angle like this is not always going to match the arc measure on the inside right there. That was just a pure coincidence. But our angle measure is 45 degrees. All right, number 7, here we have two chords that are intersecting inside the circle. So we're going to be using our formula of adding our two arcs to get the inside angle. And this picture might look familiar. We've done things with this picture in the last couple lessons because we have a diameter that is perpendicularly bisecting a chord. And that would be helpful if we were trying to find, say, the measure of this one of these two pieces. But here we're trying to find the measure of the arc. So we don't need to worry about that conjecture. So we are looking at this arc plus this arc divided by 2 is going to give me this angle, which does happen to be a right angle. So 120 plus my missing arc of x divided by 2 will be 90 degrees. Multiply by 2 on both sides. And we get 120 plus x equals 180 degrees. Subtract 120 from both sides. And our x is 60 degrees. All right, number 8, our intersection point is outside the circle here. So we are going to be looking at the formula of far arc, subtract the near arc, divided by 2 will give me that angle of 30 degrees. So our far arc is 10x plus 8, subtract the near arc of 5x plus 3. Hopefully you've already noticed it and you're sort of shouting it at me, but we need to subtract this entire expression, so we need parentheses to make sure we do that. And if we don't have those parentheses, that will be wrong. Divided by 2 is going to equal 30 degrees. And so when we combine like terms on the top, we're going to need to distribute this negative sign through. So we get 10x plus 8, subtract 5x, subtract 3. Combine like terms, 5x plus 5. And then we go ahead and solve for x. And keep solving, keep isolating. And we end up with x is 11. All right, we're up to the last two questions. Number 9 looks like we don't really have enough information, but we actually do. Here we have two tangents that are intersecting outside the circle. So we have these two tangents here. And we know that angle is 65 degrees. And then there's two arcs. We have the far arc out here and the near arc here. And we don't know those numbers, but what we do know is that the total of the two of those is 360 degrees. So if we were to name the near arc x, and since the total of them must be 360 degrees, then the far arc we could name as 360 minus x. Make sure that makes sense of how we did that. And you could have named either one x. You could have named the far arc out here. You could have named this one x and then named the other one 360 minus x. I just chose to do it this way. It will actually make the next step a tiny bit easier, and I'll show you that when I get there. But just know that you can do it either way. But just make sure that makes sense. If the total is 360, if one of them is x, then the other arc would be 360 minus x. So let's go ahead and fill in our formula. If we know that the far arc, which is 360 minus x, and then we have to subtract the near arc, which is x, so minus x again, and then we divide that by 2, that's going to equal 65. Just as a note, if we had done it in reverse, and if, I'll write this scenario in red, but if the far arc, if we had called that one x, and then called the near arc 360 minus x, when we wrote the formula out and we did x minus 360 minus x, we would have needed parentheses like we did in the problem earlier because we're subtracting an entire expression. And then the rest of it would be the same. But I just wanted to point this out to you because it's just something really tricky to remember that you need those parentheses there because this negative would then have to get distributed when you went ahead and solved that equation. So just something to point out to you. I'm not going to solve it that way. I'm going to go back and solve it the first way, but just wanted to remind you about that step. Okay, so let's go ahead and finish this question. Let's combine like terms. So we get 360 minus 2x divided by 2. And we're going to multiply by 2 on both sides. That gives me 360 minus 2x equals 130. Let's subtract 360 from both sides. And we get negative 2x equals negative 230. If I divide by negative 2 on both sides, I would get a final answer of x equals 115 degrees. Okay, for our last and final question here, we have something a little different. We have a regular pentagon inscribed in our circle. And we also know that GA is a tangent, and we want to find angle AGD. So we're looking for this angle right here. And if we just focus for a second on this angle, we can see it's made from this tangent and this secant. So the general idea we're looking for here is we want to do this far arc out here, subtract the near arc in here to divide by 2 and then get our angle measure. Well, let's see if we can figure out some numbers because we don't have any numbers in this diagram at all. Let's go back to the fact that we have a regular pentagon. Because it's a regular pentagon, all of my side lengths of that pentagon are the same. So we know that these are all congruent. And we know a conjecture that tells us if we have congruent chords, then they cut off congruent arcs. So the 5 arcs outside of those are all the same. Well, since a total circle is 360 degrees, if we divide that by 5, then each of those arcs is equal to 72 degrees. So I'm not going to label all of them. Let's just label the ones that we need. So this inner arc, the near arc, that one is 72 degrees. And then these 2 yellow ones, each of those are also 72 degrees. So if we go to our formula, that tells us we're going to take the far arc. So that's 2 of the 72s. That's 144. Subtract the near arc, that green one, which is 72. If we divide that by 2, we should get the angle that we need. Well, 144 minus 72 is 72. 72 divided by 2 is 36. And that is the angle that we need.